Hey everyone, just checking in with you here at the end of week 3, beginning of week 4. I actually created a long blog entry like I'd done in previous weeks and typed up all the text. And I was a victim of T-square, like a couple I should say, very few of you have reported. And so I can feel your pain. I understand. Sometimes T-square is just does not cooperate well. So I'm just posting the video this week, and hopefully that won't be a problem for many of you. I'm here at the seismic offices here at Georgia Tech, and they're moving some stuff around, so you can see in the background looks like a warehouse a little bit. So anyway, I wanted to talk to you a little bit about how well you're doing. You guys are really engaged, and I'm getting a lot of positive feedback both in the surveys, in emails, and just general comments that I'm getting here and there. Seems like you all are engaged with the course. You think the content is good. The activity and the experience of seeing a PBIL is good. So that's really great, and I love hearing all that nice stuff. But do let me know if there's other issues. I know there's some technical issues that people have been having. Sometimes certain browsers, Google Chrome, I think, has been offering some problems. Be sure if you're having technical problems, you can't post assignments, you can't find something, or you're unable to watch a video or something like that, that you contact the tech support link at the contact instructor button. Those folks will be able to help you much better than I can. 3 impressions that I have from this week I wanted to sort of talk about. One, I wanted to talk a little bit about where we are in the experience and how we kind of got here in this RRV experience, that is. If you've noticed, we haven't been talking about gravity, and we haven't been talking about drag or air resistance up until this point. We really waited until we got through those investigations, and that's because in inquiry and in project-based inquiry specifically, we want you to have experience, we want you to formulate ideas, we want you to sort of put your conceptions out on the table and look at possible solutions and think about changes you can make to things and investigate those things a little bit, try to do a controlled experiment. And then the science comes in. Then some of that sort of content knowledge and that research that we want students to do, whether it comes from the textbook or lectures or maybe their own investigations of things, we really want them to have a need to know before they go out and experience that stuff. And this is somewhat counterintuitive. In a lot of places in school and more traditional type classrooms, you'll get the lecture and all the vocabulary words up front, and you'll be told what the idea is and how it works. And then you go to the lab and you see an example of that. And you see it, in practice. Here, first I'm going to tell you how it works, and then I'm going to show you how it works. And what we're trying to do here, right, is flip the script. We want you to have the experience first and generate questions and wonder why and try to make connections in your head about how things are happening. And then when you start to get the information about gravity and air resistance basically governing this entire thing, you start to make connections to all the variables you changed. So that's a major point to understand, that when you design a PBIL, when you design any inquiry-based sort of experience, you want them to wonder why something is happening. Then you want them to engage with that phenomena and make changes to it and try to control it and sort of investigate the pieces of it. And then that science content can come in. The tell, as I call it, can come in. The teacher can now say, well, let's look more specifically at how this is really working. Now, the tell has to be done in such a way where it's still interactive and dynamic. You can see how the motion storyboard might be used to get students' conceptions and ideas and work on their sort of understanding of how force and motion is working, how to identify forces, how to use the concept of net force to analyze a motion event. And done in that way where it's interactive, students still have ownership of it. They can still give their ideas, and then those ideas can be sort of molded and shaped and corrected if they need be. But it doesn't mean that it's sort of direct lecture or sort of, go to the book and find the answer kind of thing. There's still a collaborative experience. There's still an interactive experience with it. One of the things I wanted to point out was that you all did a very good job of planning, and I'm sure you watched the video about the importance of planning and why students need to engage in that activity. Almost equally important is for students to carry out those investigations, formulate sort of trend or look at the data and figure out what's going on, and then go back to the class and say, here's what we think. Now, you all did this as individuals, and that was basically mandated by what we have available to us here in terms of this distance learning experience. But you can imagine in a science classroom, where I would take the class and put everybody in groups of 3 or 4, and half the class would do paper clips and half the class groups would do wing length. And even though everybody, you've got all these other groups that are doing the exact same variable, you're going to get different data and you're going to get different results because they all came up with different experiments. They were all testing the same variable, and they probably were changing things in very similar ways and trying to control other things in similar ways. And so the trends might look similar, but there's going to be differences in the raw data. And just to show you an example of this, I've made available to you Group 3. Go to their Assignment 8 group forum discussion. I've made it open so that everybody can read it. You can't comment in it, but you can read it. I would like you to look at the sort of back and forth in the exchanges. They talked about how they did their procedures differently. They talked about the data turning out differently. They talked about certain mistakes they made. And they went back and forth and made suggestions. Now, this is something that science teachers kind of readily do in this sort of quick way. I mean, it's something they're interested in doing. And you might say, well, students aren't going to do that. Well, I can tell you that I have had 8th grade science students have that exact same conversation. Now, it took a little bit more facilitating and scaffolding, and it wasn't the first time they had had conversation about experimental results. The first time they do it, they're pretty quiet. They don't know how to behave this way. They don't know how to act in this way because we don't teach them how to do that. They don't get a lot of opportunities to act that way in school. But when they do sort of develop that competency in that, and they do sort of develop the ability to carry on those conversations, you'd be surprised how similar it looks to this exchange between the teachers in this group. I'd also like to point out there were other groups that had similar exchanges. They weren't the only ones, but I just thought it was a good example. So even though they all did very similar procedures and they all had been talking about these ideas and planning these similar ideas, they came up with different results and they made mistakes. In a real science classroom, what I would do is have those groups present those things on posters, and we would look at the similarities and differences between groups that tested the exact same variable and probably got very similar results in terms of trend. If there was a group that had wildly erratic data or didn't collect enough trials to show trend in a true sense, or didn't change the variable enough to see how the trend was going, I'd make them go back and redo the experiment. Other groups would then move on to other changes that they wanted to make to the RRV. So you were getting a little bit more of a truncated experience here. I might have students go through this investigate, present cycle 2, maybe 3 times, depending on how much time I had left in the class for this particular activity. But then once that's over and students try to explain what they think is going on here, that's when we come in with the science. So you can see how the first point I made earlier today and this one are definitely related. The last thing I'd like to point out in the blog this week is that you all are doing a really good job of sort of assuming the role well, and now this sort of science content delivery is there. There's a place for lecture, and there's a place for explaining results and helping people make sense of things, and you have to get a read on your class when it's right to do that. But you don't want to do it before this moment, and you don't want to have students confused because you explain too much. Give them a chance to give their explanation, then give them science, then give them another chance to go back to their explanation, and maybe you have to do more science. This is also the time when you want to start bringing in other examples. We don't want to just be stuck in the idea that gravity and air resistance work on an RRV. We want to talk about other things that fall. We want to look at other ways in which objects move under the influence of a lot of forces that produce a net force potentially and create changes in motion we call accelerations. The whole point of this is that we do have goals for learning that are rolled up in content standards and in science standards, and we've got to address those. And so you can't just stay in the challenge. You always want to return to the challenge and say, what are the implications of this conversation? Or when I showed you this example of a car moving across the floor and you filled out a motion storyboard for it, what does that mean for our RRV challenge? That's really important. But make sure that you are giving a variety and that sort of thing. Keep up the good work. Let me know if there's any problems. You always can contact me at the Contact Instructor button, or you can leave some comments here. And have a great week, and everybody have a nice holiday weekend too. Take care.